Last video we learned that cavitation bubbles do not appear from nowhere. They always grow from microscopic nuclei. But this creates a question. According to physics, these tiny bubbles should actually disappear after some time. Gas inside a bubble diffuses into the surrounding water until the bubble dissolves completely. For example, if you blow a tiny air bubble into still water, after some time it becomes smaller and disappears because the surrounding water absorbs the gas. So, if every tiny bubble dissolves naturally, then why do pumps always have cavitation nuclei? That's exactly the question this presentation answers. This slide compares expected versus observed. Expected by physics. If water is not saturated with air, gas molecules diffuse from the bubble into the surrounding liquid. Diffusion means molecules naturally move from higher concentration to lower concentration. Therefore, bubble becomes smaller and then disappears. But in reality, engineers observe something very different. Even after long period, hours, days, months, these nuclei remain inside water. Whether it is pumps, pipelines or hydraulic turbines, nuclei are always present. So something is preventing them from dissolving. Let's see what is that. This is the expected explanation. The tiny gas bubble is usually not floating freely. Instead, it is attached to a microscopic solid particles. These particles may be dirt, rust, corrosion product, tiny mineral particles or other non-wetting impurities. The gas molecules stick to these particles by a phenomenon called adsorption. Remember, adsorption means molecules stick on the surface and absorption means molecules go inside a material. So there is a big difference between adsorption and absorption. So here it is adsorption, not absorption. I hope this is clear. The dirt particle acts like an anchor because the gas is attached to the particle. It cannot freely diffuse into the water. Therefore, the nucleus becomes stable and survives for a very long time. Easy example, imagine a balloon floating in the air. If nothing holds it, it flies away. But if you tie it with a string, it remains in one place. Similarly, gas bubble is a balloon and dirt particle is a string. The particle anchors the bubble. This explains why nuclei survive in unsaturated fluid. As you can see in the picture, gas held on a dirt particle. This is why engineers assume that cavitation nuclei always exist. Experience shows they are present wherever liquids are transported. Examples include centrifugal pumps, pipelines, turbines, hydraulic machines. And the interesting point is that even ultra-pure, deaerated boiler feed water still contains enough nuclei. In fact, if absolutely no nuclei existed, even boiling inside a steam generator would become extremely difficult because boiling also starts from microscopic bubble nuclei, that tiny, very tiny thing. So practically speaking, engineers never assume perfectly nucleus-free water. Now, here is the key takeaway for today's session. The key takeaway is that cavitation nuclei survive because gas is adsorbed onto microscopic dirt or corrosion particles. These nuclei are present in almost every engineering system. Once the local pressure falls sufficiently low, these stable nuclei begin to grow into cavitation bubbles. For more fun and interesting topics, keep learning with us and explore our website www.capacira.com. Thanks for watching.